significant, because if I put a -3 here, here, right, that's going to actually reflect the whole thing over, won't it? So there's an infinite number of answers. I want to show you by going to Desmos and typing this in, and let's see if what we have. All right, so I'm going to hide that. So I'm going to type in the first one I did. I'm just going to do x plus 2 times x minus 2 times x plus 3. No, minus 3. Oops. Minus 3. All right, there we go. What you're looking at here, is an example of the polynomial function. Does it have these 3 x-intercepts? Can you all tell? See, I think I can click on it there, there, there. Look at those 3 x-intercepts. -2, 2, and 3, right? What does the left side do? Down or up? Down, right side, up. And we could tell that from here, right? Leading coefficient test on this would tell us left side down, right side up. But if I do this instead, right? This instead, I'm just going to slap a -3 in front of that. So I'm first going to make a copy of it, and then I'm just going to throw -3. Let me change it to red so you can see the two together. If I put a -3, what did it do? Flipped everything over. Whoa, something. Yeah, it flipped it, but it also stretched it, right? Remember, we were talking about transformations? So it stretched it and flipped it. But does it still have the same x-intercepts? See, the -3 has no impact on your x-intercepts. It only has to, it's either going to stretch it or possibly flip it over. So there's an infinite number of answers, yes? Let's try another one. Let's look at 48. Look at 48. Can you all see that one there? We need to come up with a polynomial function that has zeros of -2 with a multiplicity of 2, 4 with a multiplicity of 1, and a degree of 3. Okay, so they're giving you not only the 0, but the multiplicity of that 0, right? So number 48. Number 48. Okay, f of x equals. Okay, I need a 0 at what, -2 it says? So what should I put in parentheses? If I need a 0 of -2, x plus 2. Okay, I need x plus 2. What's the other 0? Let's look at the other 0. The other 0 is what? 4, so we want x minus 4 in here? Right, this right here, these would give us the 2 zeros, right? The 2 zeros of -2 and +4. But what should the multiplicity of this one be? 2. It says it right there. So I need to put a 2 here. And then the multiplicity on this one? 1. So I don't need the 1 there, but there. I put it so you can see it. Now, is this a degree 3?
Yeah.
This is degree 3. So if this is degree 3, then let me do it this way. So we would do x squared plus 4x plus 4. That's what I would get if I would square that. I would get this. I do x plus 2 times x plus 2. And then I still have to multiply by x minus 4. So we would have to do the same thing we did before. Multiply this out. Let me switch the order so that it kind of follows the same way. So I just reverse the order. That way we can do this, 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 this. Any questions on where I got these factors and where I got the 2 and the 1? Everyone clear on that? Sure? All right, so x cubed, see if I can do this without messing it up, 4x squared plus 4x, and then minus 4x squared minus 16x minus 16, and then finally x cubed. Let's see how many x squared. Oh, the x squareds are gone, yeah? Okay, and so I've got minus 12x minus 16. There it is. That's it. So what's the end behavior here? What's the end behavior? Down and up, right? Down and up. Down and up. All right. Let's look at number 54. We want to come up with the function. Oh, by the way, was this the only answer?
No.
No, because I could always have done what? Put a number in here, like a leading coefficient. I could have changed it, just thrown a number in there, and had a different answer, right? I could have scaled this by 2 or -5 or anything. So this is one answer, but it's not unique. Let's look at 54. So for 54, they want us to come up with a function again. It gives us 3 zeros, right? Doesn't give us any multiplicities. 3 zeros, a degree of 3, and a y-intercept of 16. Okay, so let's see. What are the factors? How many of them am I going to have here? I have 3 zeros, right? -4, -1, and 2. So I need 3 factors, don't I? They are x plus 4, x plus 1, and x minus 2, right? You're just always taking the opposite of the 0, right, and putting it in there? Yes?
And then you got to put the plus 16 on it.
Well, now we'll figure out the y-intercept in a second. Let's just make sure we all agree right now. This is the zeros, right? This gives us the zeros we need. What is the degree of this? 3. Now, I've done some examples where I've multiplied them out, right? And we were able to confirm the degree was 3. But we want a shorter way of doing it, so I'm going to show you the short way of finding the degree. All you have to do to find the degree is look at the x here, look at the number in front of it, and then look at the power. What would I do if I take 1x and square it? I would just get x squared, wouldn't I? Then look at the other one, x. There's a 1x here, and it's to the first power. So if I multiply that by 1x, so what's 1x squared times 1x? This is just x cubed, and that will always be that first term. Let me do it on this one. This is a 1x to what power? 1. This is a 1x to what power? 1. So 1x to the 1, right? So this is like taking 1x times 1x times 1x, and you put all those together and you would get x cubed. So I know that this is a third degree polynomial, right? Without multiplying it all out, I know it's third degree. Okay, so I have the right zeros, I have the correct degree, right? But I need a y-intercept of what? 16. So here's where this is different than the previous problems. We have to have a y-intercept of 16. So what I'm going to do here, let me erase this. I'm going to rewrite the function, and I'm going to say to myself, okay, look, I could have always put some number, I'm going to call it a, in front of this, right? I could have always put that number in front and changed, that would change the shape, wouldn't it? Might reflect it. So this is like a general answer. This was one specific answer. Here's a more general one. And what I need is a y-intercept to be equal to 16. That means when I plug 0 into the function, I get 16. Remember how to find y-intercepts? You plug 0 into the function. When I plug 0 into this, I better get 16. Yeah? So let's plug 0 into this. What is f of 0? A, 0 plus 4, 0 plus 1, 0 minus 2. What's that equal to? This is a times 4 times 1 times -2, right? Which is -8a, -8a. If I plug 0 into this function, I get -8a. What do I need that to be equal to, though? 16, right? I need that, when I plug 0 in, I need that to be equal to 16. Let me write it over here a slightly different way. I think this will make a little more sense in case you're confused. If we're saying that f of 0 has to be 16, we just found out that f of 0 was -8a, right? And that must equal 16, which means A has to be negative 2. And now what you've done is you've found the only function. It is unique, right? There's only one answer now. And that answer is f of x equals negative 2 times x plus 4 times x plus 1 times x minus 2. Nobody has any questions? No? Okay, we'll see. Let's do a quiz. No, I'm kidding. We won't do that. We won't do that. But let's see. I'm going to give you this one, and let's see if you can figure this out. All right? Look at the. I don't know if I can get it all on there. Let me see. I want to see if you can figure out how to do this one right here. Can y'all see it or not? Come up with a function that has zeros of negative 4. Can y'all read that? Does it make sense to you? You need a 0 of negative 4 with the multiplicity of 1. 0 of 0, multiplicity of 3, 0 of 2, multiplicity of 1. It needs to be degree 5, and it needs to contain that point. What does it mean, contain that point? This y-intercept meant this, right? When we plug in 0, we got 16. What does containing that point mean? When we plug in what, though? What's that? When x is negative 2, it needs to spit out 64. See if you can figure this out. I'm going to give you all 7 minutes. Help each other out. We'll see what you do in 7 minutes. Help each other out if you need to. Pardon me? Why don't you try and figure that out? Yeah, what does it mean to be a 0 of 0 with a multiplicity of 3? Don't give it away if you know, but I want everyone to think about it. And in case you can't read that, I'll put it up here. So you want to find a polynomial zeros of negative 4, multiplicity of 1, 0 of 0, multiplicity of 3, 0 of 2, multiplicity of 1. It needs to be a degree 5. And the point negative 2, 64 needs to be on that graph. All right. Just unmuted. What are y'all thinking? Y'all making any progress? You still having trouble with that one or no? You figured it out? Okay. Who has questions? Yeah?
I don't know. I feel like I can't make it past this part.
So x plus 4 to the first power, good. X plus 0 to the third, good. Okay, now, that's one specific answer, right? Mm-hmm. But you need to remember that when you do whatever you do here, right? You can always have some number out there. You don't know what it is. It could be any number you wanted, right? Okay. So that would be your general answer, all right? And then you know that when you plug in, what does it mean to say that negative 264 is a point on the graph?
You substitute x for negative 2?
If you replace all your x's with negative 2's, that answer should spit out what? 64. And that should allow you to solve for A.
Okay.
Make sense?
Yeah. Makes so much sense.
Oh, okay.
Yeah. So I'm going to work through it. I just can give everyone just another minute.
It's so small.
Okay. You all ready to talk about it?
Yeah, let's talk about it.
Let's talk about it. All right, so here's the deal. I need to come up with a function. Now, I'm going to leave a space in the front for, for what I'm going to do in a second. I'm going to leave a space here. I know that I need the factor x plus 4, and I need that raised to the first power, right? Because that's what it means to have negative 4 as a 0 with a multiplicity of 1. Now, this one confuses students because you're like, okay, what do I do? Because here, I just did x plus 4, right? Here, I do x minus 2. So I'm always doing the opposite of these numbers. What's the opposite of 0? 0, right? So you can either say x plus 0 or x minus 0. What do you want me to do? X plus or x minus? X plus 0. And then that needs to be to what? The third power. And then I have x minus 2, and that's to the first power. Yeah? Okay, now what is x plus 0? X, right? So isn't this just x cubed? That's just x cubed. So maybe I write it this way instead. X cubed, x plus 4, x minus 2. You see, that's a cleaner way of writing everything. Do y'all see where everything comes from? This is x to the third power. Then x plus 4, and then x minus 2. I don't need to write the ones. I mean, this should be the function, right? But that is a specific function. That's the one I've chosen. Generally speaking, there could be any number out here, so I'm going to put it A here. There could be any number out in front of this, right? That A is either going to stretch it out, or if A is negative, it might flip it over, right? So this would be our general answer. We have one more condition, though. We know that this point must live on the graph, right? So if this point must live on the graph, then that means when I plug 2 into the function, right? Sorry, negative 2. When I do negative 2 into the function, it needs to be equal to 64. Well, what does it mean to plug negative 2 into the function? It means replace all your x's with negative 2's here. So I have a, negative 2 cubed, negative 2 plus 4, negative 2 minus 2 must equal 64. See what I'm doing here? I'm saying this must be equal to this. What's negative 2 cubed? Negative 8. Negative 2 plus 4, 2. Negative 2 take away 2. Negative 4, right? Not 0. Equals 64. Isn't that 64 over there?
Yes.
No, sorry. It's positive 64.
A is 1.
So A is 1. So 64A must equal 64. So A must be 1. Right? A must be 1. Which means my final answer is f of x equals, that A should be a 1, right? X cubed plus, x cubed times x plus 4 times x minus 2. All right, if I graph this, I should see the x-intercepts, right, that I'm supposed to have, right? And it should go through the point negative 264. Yes? Are you allowed to? Yes. I mean, our ultimate goal here in this class is actually to start with the multiplied out form and graph it. But we begin by having it already like in this nice form like this. So it's easy to see the x-intercepts and the multiplicities. But yeah, so you leave it like this or multiply it out, your choice. Okay, understand? All right, what you are looking at over there, what you're looking at on the board there, is a degree 5 polynomial. I'm telling you that, okay? That's a degree 5 polynomial. What's the function? Tell me what that function is. Okay, I'm telling you it's degree 5, right? Everyone take a look at it. Think about it for a second. I'm telling you it's degree 5. All right. First volunteer, raise your hand. Give me one of the zeros. One of the zeros. Okay, you have a zeros, my zeros. You have negative 2, you said? Yes? 3 is another 0. And 5. Okay, now, new volunteers. At negative 2, what's the multiplicity?
Even.
Volunteer? What's that?
Even.
It's even, right? It's even. Why do you know it's even?
Bounce.
At negative 2, we bounce, don't we? So I know that this is even. Do I know if it's 2 or 4 or 6 or 8? I don't, right? Well, I kind of do, right? It's not 6. Why? Because I told you this is a degree 5, right? Okay, what about at 3? Somebody else. Tell me the, someone else. Someone else tell me the degree at, it crosses at 3 it crosses, so what does that mean about the degree?
It is
Odd, right? We know it's odd, okay? And then somebody else tell me about the degree at 5. It's even, okay. So if this is a degree 5, I'm telling you this, I told you this, right? I'm telling you it's a degree 5 polynomial. If it's a degree 5 polynomial, and we have to have an even, and an odd, what are the only possibilities? 2, 1, and 2, right? 2, 1, and 2 are the only multiplicities possible. Otherwise, we're going to have more than 5 degree, right? With me? So this degree, we knew it was even, but it actually needs to be 2. This is odd, it has to be 1 in this, right? There's no other way to do that, right? To get a degree 5? There's no other way. Now, what if I told you it was degree 7? Well, then there's a couple of different possibilities, right? Because you could have, this could be 4, and this could be 2, and that could be 1, or you could have 4 here, 2, and 1. See what I'm saying? There's some ambiguity there. Or you could have what? 2, 2, and 3, right? So I had to be very specific and make sure that there weren't all these different cases, all right? So far, so good? Yeah? Okay, let's see if we can come up with a function. Now that we've done a few of these, I'm going to go ahead and throw the a there now. And I need one factor to be for this one, right? So x plus 2. And I need the degree on that to be 2. And then I have x minus 3, and the degree on that is a 1. And then x minus 5, and the degree on that is 2. Right? So this is my function up to now, right? Anything else? I gave you another piece of information that's very important. I gave you a point 436, right? That means when I plug in 4 into the function, it should spit out 36. So now, the fact that f of 4 equals 36, do y'all see this is the exact same picture, same problem that we just did, except with a visual instead of me writing it down? So if I plug in 4 into this, let me do that. Let's see, 4 plus 2 squared, 4 minus 3, 4 take away 5 squared must equal 36. That's just me replacing all my x's with 4's. And I'm going to solve for a here. So 4 plus 2 is 6. 6 squared is 36. 4 minus 3 is 1. 4 take away 5 is negative 1. But I'm squaring it. Negative times negative is positive. So we get that. Hey, a is 1 again. I made up the problem. So a is 1. So our final answer is this with a 1 in front. All right. This all making sense to everyone?
Yep.
Yes? Okay, so for your homework, we're not done. Don't get all excited. Okay. So for your homework, right, so far we've done the first group here. I think that I've hopefully made that make sense. There's more, though. Let's take a look at number 60. So what they want you to do here, let me just kind of go through the instructions. It says, list the zeros and their multiplicities. Determine if you cross or touch at those x-intercepts. Determine the max. Okay, we're going to skip part C. We're not talking about, I'm not going to talk about turning points in this class, so we're not going to do C. Determine the behavior. That is, it's basically determine the left and right hand behavior. All right. So let's look at number 60. So for 60, we have f of x equals 4, and then parentheses x plus 4, and then x plus 3 cubed. All right, so for this one, first let's start with the zeros. Where do we have zeros? Negative 4 from here, right? Negative 4 and negative 3, right? What about this? This is the a, right? This is not a factor. This is just a. So you don't say 4 or negative 4 from this. You ignore that. That's your a. You get your zeros from these two factors. Now let's talk about multiplicity. What's the multiplicity of this 0? 1. Okay, that means we cross or touch there. I'm sorry, cross or bounce. We cross. Okay, we're going to cross there. All right, this has a multiplicity of 3, right? That's odd, and so we cross there as well, right? We're going to cross and cross at these two x-intercepts, or these two zeros. And then the last thing it wants is to know the end behavior. It wants to know what's happening off that leading coefficient test. So this is where we do that shortcut, right? Pay attention. I'm going to do the leading coefficient test, all right? But what I'm going to do is I'm going to take this number 4, okay, times, this looks like 1x to the first power, 1x to the first power, And this looks like 1x to the third power. Do you see what I'm doing? Instead of multiplying everything out, I'm just looking at the x and what the power is, the x here, and the power, and then the 4 is going to also come. Because if that's a -4, it's going to flip it over. So I need to make sure I take that into account. What happens if you multiply all that together? You get 4x to what power? The 4th power. That's what this thing looks like. What's the degree of this? The degree is even, and the leading coefficient is positive. So up. And in the middle, actually, I don't know the middle, but I actually do. I don't think it's asking you to graph it. It doesn't ask you to graph it, but could we? We could, couldn't we? If they asked us to graph this, we have an x-intercept at -3 and at -4. I know what the left side goes up, the right side goes up, and I know when I draw this, I cross through and cross through. It almost looks like a parabola, doesn't it? It's not exactly a parabola, but it kind of looks like one.
Wait, can other functions, can other functions look like a parabola even if the exponent is raised to a higher number?
Would need to be even.
Okay, so if it's like 8x to the 8th power,
It could kind of look like a parabola. It's not exactly the same, but if you're just looking at the sketch, you may not be able to tell it's not. But a lot of times when you have this is a 4th degree polynomial, a lot of times it doesn't look like this. It'll look more like that. You'll have some little humps in there. This one,
have the little x-intercept, it's like it curves up.
yeah. So here we would have what, 3 x-intercepts? Something like that, or 4? They're all different, but it resembles a parabola.